So how do you make a library? Well, there's an enormous amount of different protocols, but they're all more or less based on this simple protocol. So you start from genomic DNA. So this is a library for DNA-seq, and you cut the DNA into pieces, typically by sonication. Sonication is a random process, so you will get small and you will get large fragments. So the large fragments are not very useful, and the very small fragments are also not very useful. So the second step is a size selection. So you're going to select fragments of a certain size, and that's typically between 100 and 800 base pairs for Illumina sequencing. So once you have a collection of size selected DNA fragments, you're going to ligate adapters to the fragments. And you will use two adapters. As you can see here, you have red adapters and you have blue adapters. So they have different sequences. So these two adapters are ligated in such a way that for every fragment, you have one blue adapter on one side and one red adapter on the other side. Once you have a library, a collection of DNA fragments of a certain size range with adapters at both sides, you're ready for doing the sequencing. So this is what is being sequenced. So how can you ensure that you have the different adapter at the 5' end and on the 3' end? This is done by using these forked adapters. So this is what they look like. And they are built in such a way that they guarantee to have a different adapter at the two sides of your fragment, as you can see here. So whatever you do, you will always end up with a blue adapter on one side, and in this case, a purple adapter on the other side of your fragment. So I know that in my graph here, in my figure, it looks like all the fragments have a blue adapter at the 5' end and a red adapter at the 3' end, but in reality, that's not the case. They will have a blue and a red adapter, but where each is different for every fragment. So some fragments will have the blue adapter at the 5' end, other fragments will have the blue adapter at the 3' end. So you have no control over this.